you help me out, man? If someone asks a question in the chat, if I'm just so locked in doing this review stuff and I don't see someone with their hand raised, I don't see someone asking a question, can you just interrupt me? Just say, yo, Atterbury, hey, help me. There's a question. And then that'll break me from being so focused on this that I can focus my attention on you guys. Okay? All right. So I'll read this out for you guys. A tree farmer hires a botanist to evaluate a blight that seems to be affecting his trees. Now, blight is a cool word. Okay. I had to Google it. I've heard it a bunch, but I never really knew exactly what it meant. A blight is basically like a disease that a plant can get. Okay. A blight is something that is like usually caused by like a fungus or something that affects plants, that kills plants. So this farmer hires a botanist, which is like a professional in plants, to see what's going on with his trees. Okay. The trees are planted in horizontal rows on a hill, and the blight seems to be a bigger problem near the bottom of the hill. The farmer wants to know the extent of the damage to the trees. Since the trees must be destroyed to examine them, the botanist doesn't have time to examine all the trees. So she will select a sample. Several plants for choosing the sample are proposed. Name the sampling strategy in each. So give you a heads up. They don't tell you here, but down here, they tell you there's 4,237 trees. So put that into perspective as you're doing this. Okay, that there's over 4,000 trees on this farm, orchard, whatever it's called. Okay, but here's some ideas of how they want to do their sampling. So you're gonna have an actual your quiz that's released to you guys is very similar with a different situation, but it's the same thing with 4 sampling strategies, and they're explained in context. And your job is to explain what kind of sampling strategy is used for that plan. Okay. So here's the first plan. Randomly select 3 trees from each row. Okay. And then I'm assuming from that point, you look at the data from there. So because you're separating the orchard or the farm into these horizontal rows, those are little groups, right? And then from each group, you select, 3 trees from each one. That is called a stratified sample. Okay. Each one of those groups, each one of those rows is a strata. And remember, the process for doing the stratified sampling is to separate your sample into different groups called strata. And then from each strata, take a random sample from, some random samples from each one. That's what stratified sampling is. Okay. Stratified. Basically, fancy way to say it's groupified. Okay. Lay out a grid on a map of the hill. Okay, this is the second one. So you lay out a grid on the map of the hill. So you take something like, you're taking something like a map, and then you make like a grid system. Okay. And then you're going to randomly select 8 squares from the grid and check all the trees in those squares. So that would be like a set of numbers using a number table. You're somehow, some way going to select 8 random squares in the grid. I don't know how big the grid is, but maybe it's 10 by 10, 20 by 20. I don't know. There's 4,000 trees, so I don't know the size of the grid. But regardless, you're making groups, and then you're going to select some random stuff out of that. And then out of those random things, you're then going to check all of the trees in those squares. So let's say this one, and that one, and that one, whatever. That's a different kind of sampling technique. That one, the big key indicator here is this. Okay. After you've put them in groups, okay, or strata, right, you're then going to do this whole idea of what's called like a little mini census within that smaller group. Okay. So it's all these little small groups. It's not just rows, it's rows and columns split into little small things. And then you select a few of them and do all of it. This big keyword there, that check all, it's like a census, but it's like a little mini micro census. That's called clustering. Okay, that is a cluster sample. Okay, that's called a cluster sample. The next one, randomly pick a number from 1 to 30, start at the tree at the position in the first row, then go to every 30th tree after that. So let's say a random number from 1 to 30, you use a random number table or whatever you do, and you pick, let's say 25. You go to tree number 25. Then you walk it, you do a sample on that one. Okay, or you do a test on that one, whatever. You go up 30 trees, do that one. 30 trees, that one. 30 trees, that one. 30 trees, that one. That sounds very systematic, right? And in fact, that's the name of it. Okay. Systematic style of doing your sample. Okay, the last one here on this list is check the 10 trees closest to the parking lot where the botanist parks her car. Okay, so imagine you have like a hill, right? To say it's on a hill. So there's, I'm assuming there's two options. Okay, you have these trees along this hill, and you either have a car parked here or you have the car parked here. Okay, depending on where the parking lot is at the hill. So if you pick things that are just close to you, that's generally the big like key indicator for what kind of strategy this is. Okay. That strategy of usually finding like a close proximity of where you're at, like the easy way. Okay. That easy way or lazy way, it is a method to sample. Okay. It's almost like, it's like if you're like sampling soup, you just get that little soup that's right there. You don't got to like dig some random like sample in the middle of the soup. Just take a sip from the top. That's a legit method, right? To sample soup. But for testing trees and like a disease, like a disease that's passing from tree to tree to tree, you might not want to just pick some small group by a parking lot. Maybe you have one tree from there, one tree from somewhere else. But that strategy, and it's generally a flawed strategy. That's that convenience sampling. Okay. Okay. Convenience or convenient or whatever. That is whatever's convenient for the person taking the sample. Oh, I parked here. I'm going to test these trees. Very convenient. Super convenient. In fact, so convenient it sounds too good to be true. It means your data is probably going to be all messed up. Okay. So once again, some things to look for. This one, remember, I put them into groups. From those groups, they selected a couple of random ones, whatever. Okay, those groups are called strata. It's called stratified as the sampling strategy. The next one, it was this whole thing where they did this big thing of like making these groups into these small groups. There's some randomness involved, whatever. But then all of a sudden it said, hey, with these small groups, we're going to check all of the things in that small group. Okay. And then compare that stuff. Okay. That's the cluster. This next one, you see this whole thing about like every this or whatever, like that's kind of like the big key thing there. That is a system that's called systematic. And last but not least, you see this thing about close proximity. That's usually the big indicator that's going to be the convenience. One other one to kind of keep in mind is SRS. Okay. That was that simple random strategy and or simple random sampling. Sorry. And that would be if you gave every tree a number. Okay. And from there, you just selected like, 10 trees or 100 trees or whatever it is compared to the whole orchard. Okay. That would be a simple random strategy where every tree would have an equal chance. Okay. Like a big lottery system, like pulling a tree's name out of a hat. Okay. That's basically what you're doing with simple random strategy, which is not one of these strategies, but we do see it in question 3. All right. Question 2, explain why the last plan suggested above, selecting the 10 trees closest to the parking lot, which we already said was convenience, okay, why it might be biased. So be sure to name the kind or kinds of biases you describe and link it to the variable interest, okay? So I could see 2 different biases happening. Whenever you do the convenience thing, so whenever I think of a convenience thing, the best example I can give is if I gave you guys a task of doing a survey of Serrano High School students, if we were back in the classroom right now, and you went out to like, let's say the lunch area, and you sampled people that were right there in front of you in the lunch area. Okay. That would be a convenient style of sample because they're right there in front of you. Okay. When you do stuff like that, generally speaking, 2 type of biases can happen. Okay. The first one is you kind of get results that are too low. Like think about the Goldilocks type stuff where it's just too low of a number. It's underrepresented. Okay. Or it's the other thing. What's the other Goldilocks thing? It's too much. Okay. Or it's overrepresented. Okay. It's like, it's too much. There's too much group think in that little small area. Okay. People are more likely to respond to seeing if they hang out, if they're close together. Okay. Things are very similar, right? When they're usually close together. So what kind of bias that is considered is either an under or over coverage. Okay. So remember how the farmer said something about the bigger problem is near the bottom of the hill? So if this botanist parked her car at the bottom of the hill, she might encounter, using this sampling method, an over coverage. Okay, like just too many trees are sick because, yeah, she picked the ones that are already identified as being sick. If she parked at the top, if that was a parking lot, sorry, my voice is gone. If she parked at the top, where we know the bottom is where a majority might be, the top might be an underrepresentation. Okay, we don't know where the parking lot is. It did not tell us, but we imagine it would either be over or under depending on where the parking lot is. Okay, that would be that might be a bias. Is it guaranteed? No. Okay, but it might be. All right, be sure to name the kind of biases you describe and link it to the variable of interest. So long story short, the parking lot might be at the top of the hill where we know already the biggest problem is at the bottom, okay? Okay, so here's my explanation: under or over coverage. Okay, you might get your numbers too big or too small, like artificially, like it's just right. Remember, a bias is a systematic error. Okay, it's your sampling style, your sampling strategy was flawed from the plan. Okay, and from those flaws, you might have too big of a number or too small of numbers, and this would happen because the parking lot might be at the top of the hill, and when the main problem is said to be at the bottom of the hill, and vice versa. Okay, where she might be at the bottom of the hill, and so on and so forth. We're not quite sure. There's not enough information. But regardless, a convenience sampling strategy is generally considered either underrepresented or overrepresented. Okay, under coverage, over coverage. For your quiz, just giving you a heads up, this is going to be a fill in the blank. The rest is going to be written for you for the situation. It's going to be the answer key answer, but you have to describe what kind of bias might happen. Okay. So this I have to go in and grade. I do have it set to a certain phrase, like a certain like word or words. And if you hit those right words, you'll get the right. If you're close, it might mark it wrong. And then I got to go in and correct it. Okay. So just be mindful. You have to enter in what kind of bias you're going to see. Okay. Or what kind of bias would you expect? Or maybe, something like that. Just type in what you think is right based on the information they give you. If you're in the right area, if you're close enough, okay. If it looks like I know what you're talking about, then great. Okay. If you put like stratified sampling and it's like, wait, that didn't even answer the question, then obviously you'll be wrong. Okay. It'll be worth 2 points in your quiz to identify the bias. Okay. And you can use the rest of the answer as a tool to help you write that out. Okay, I would use that. All right, this next question number 3, says there are over 4,000 trees. Okay, there are 4,237 trees on the hill. Explain how to use a random digit table to select a simple random sample of 20 trees. Then use the random digit table below to select the first 5 trees for your samples. There's 2 things going on here. Okay, there's this. Let's call that number 1. And this, okay, that's number 2. Okay. So thing number 1 says, make a plan. If you're going to select 20 trees at random out of these 4,237 trees, okay, if you're going to select 20 trees and you want to do it from a simple random sample style, right? Okay, an SRS, simple random sample. How would you do that? Okay, that's what we're going to do. And that's what you're going to have to do on your test. I'm trying to look right now. I'll have to double check. But pretty much all I'm mainly looking for this question is the plan, double check, triple check. But you should probably also do the, it shouldn't be too difficult to perform the actual task of using the table. This will be worth 2 points as well. This one here, you'll type everything out and I will have to grade it by hand. So just know if you guys submit it early, you guys can do this today. I'll have this graded by tomorrow morning. Okay, I'll do it probably tomorrow morning before 10 o'clock. I've got the morning off. I got straight off. So tomorrow morning, my plan is to get these graded. So if you don't do it today, you might not know your score until like Sunday or Monday. Okay, which is fine, not the end of the world. But if you want to make sure you're doing everything right and trying to go for that 100%, get it done today, do your best, and then, you know, tomorrow morning, whatever, check your grade, you know, tomorrow afternoon, whatever. And if it's grade you don't like, then feel free to do it again, do it the weekend, whatever. Okay, come back during tutoring tomorrow at 2 o'clock. Okay, and I can explain to you where the errors are and where you can make your corrections. Okay, so in SRS, using a random number table or a random digit table, you see how it's 4,000. Now we haven't really done this. This is kind of a little bit of additional instruction from last chapter. We may have talked briefly about it, but I'm going to go a little bit more detail and show you exactly how to do this. Okay, we have 4 digits. So we're going to go ahead and we're going to label these trees. So each tree is going to get a number from 0001 all the way to 4,237. So we're going to go ahead and say, so by number them, I mean, just give them like these labels, you know what I mean? Like just assign those to the trees. You don't got to actually go out there with a notepad or anything and put the numbers on it. Okay. So we number the trees basically from 1 to 4,237, but I'm going to put these zeros here for a reason, and I'll show you momentarily when I finish the statement. Okay. We're going to select the first 5. We're going to select the first 20 trees because it wants us to do the 20 there. So I'm going to use this language right here. I'm going to say select the first 20 trees and then ignore repeats. Okay, so if let's say tree number 1 got selected, tree number 1 can't be selected again. Okay, so that's what it means by ignore repeats. Then I'm going to say ignore numbers outside of the range. So numbers that are like 0, 0, 0, 0, you know, like 0, ignore it. Okay, that's not a tree. If I get 4, 2, 3, 8, that's outside of the range. Okay, 5,000 outside of the range. Anything above this number is outside of the range. So, bam, that part's done. Okay. Now we're going to use the random digit table to select just the first 5. We're not going to do all 20. We're just going to do 5, and I'm going to show you how to do that. So in the past, we were usually using the number like 0 through 9, and we were just going through each digit by digit by digit by digit. This time, we have to do 4 digits at a time. So right here, 0, 4, 9, 0. You see that? That represents 490. So I'm going to make a little note here. Okay, there's my 5 trees, and I'm going to write the number that I assigned to it next to each one to make sure I know I get to 5. So here's my first one. And you could, if this was like your test, your quiz, whatever, you could write 0490, but just for the sake of being clear, I'm just going to put 490 because that's what this says right here. 0490, those 4 digits back to back to back represent 490. Okay, here's the next one. 5838. Okay, that is 5,838. It's out of range, right? Cross it off. Next one, 5229. That's going to stand for 5,229, out of range. Next one is 3509. 3,000 is actually in range, right? Because we're going all the way to 4,237. So 3,509 would be my second tree that I picked. Okay, so 3,509. That's a weird comma. Okay, that's tree number 2. Next one is 1397. That's in range. Hasn't been used before, so 1397. Okay, the next one is 4953. That is out of range. The next one's 1789. So 1789 is 1,789. That's within range. Okay, we got one more tree to go. Let's see, 8181. That's way too high. That's way too high. That's way too high. So this next one is 1999, and we're done. Oh, wait, no. Yeah, that was 4. Here's 5. 1,999. Party like it's 1999. All right. Any questions so far before I go on to the last question? Kate Hill. Katie, is Katie still in the chat here? Let's see. I look down here. Kate, I see you. Kate, if you're having trouble, that's fine. Not the end of the world. Hopefully you're able to kind of pay attention and kind of follow along. This video, I'll try to get it posted by 2 o'clock. Okay. If you go to the week 1 overview and to-do list, I'm posting links from each class period of the video review. So it might be beneficial for you to stay here. If you want to sit there and just check out, maybe just, you're already logged in here for your attendance. You're good for that. If you want to just go ahead and just say bye, have a good day, go to that week 1 overview and to-do list, and you can watch that, maybe period 1 or period 2, sorry, period 3, I guess. Just a hint, period 2, it's the second time I did it today. I was a little bit more awake. So period 2 might be a little bit better, a little bit cleaner instruction than period 3 this morning. I was a little flustered because my first 10 minutes, I was just sitting alone in the wrong room. So period 2, I'd recommend go jump into that one. Okay, kiddo? So if you want to go do that, I wouldn't take offense. I'm just whatever. That might be to your best interest for this next hour. Okay. All right. So last question here. The last question says, describe the kind of bias that might be present if the botanist decides that instead of doing a simple random sampling, SRS, they'll just do something different, right? So instead of doing the SRS, what if they did this? What if they dropped grains of rice on the aerial photo of the hill and inspect the trees that had rice land on them? So let's think about it for a moment. That is my aerial photo of a tree orchard, right? The apple orchard or whatever that is. I have no idea. Okay, they say it's tree farmer, so I'm assuming it's some sort of like fruit, right? Orchard, not just like trees. It's farmer. So let's say you have a photo like this, and then let's say you've got like a 20 or 100 whatever like pieces of rice, and you're trying to figure out which one should I do. So you sprinkle it on top, and you try to just let the rice wherever it lands. That sounds fun and exciting. What's the issue with that though? What kind of bias might come up? And the bias that might come up from doing that, okay, spoilers, all right, is that some trees are a little bit bigger than other trees, okay? For one reason or another, there's just going to be a little bit of difference from each tree to tree. In fact, as I drew this, I kind of intentionally did this. Some trees are a little bit bigger. Some trees I kind of try to make a little bit smaller just to kind of just create that little effect. But the bigger the space it is on there, the more likely chance that it'll land on it. One more time. The bigger space it takes up, the more likely one of the pieces of rice will fall on it. Therefore, there will be a bias towards larger trees. Okay. So that bias basically says you're going to get not the best representation of which trees to select to sample because the larger trees are going to, potentially have that skewed representation. Like there might be more larger trees that get sampled than smaller trees, just because larger trees take up more physical space. Okay, and because of that, you don't know. They didn't give us the information. We're not professionals at this. You don't know that maybe one of the symptoms of having this blight, this disease, or this fungus that's growing on these trees or whatever, you don't know that maybe it makes them smaller. Maybe it makes them bigger. I don't know. So you're going to get either, once again, kind of this idea of potentially over or under coverage. Okay. We'll just kind of we'll leave it at that. Okay. But basically, so I probably said this with way too many words, but here's the thing. There may be something related to the blight and the size of the tree. Okay. We don't know exactly what, if there is anything at all. Okay. But we don't know exactly what's going on with the size of the tree and whether or not it's diseased. Okay. Whether or not this tree is dying. So it would probably be best that they don't do this method, okay? Because they might get these skewed data results. Like, oh my God, all these trees are all diseased, or oh, none of these trees are diseased. Look at this data I just found. Like, okay, so you're not going to get the best representation. It's going to be biased towards bigger trees. That's it. Okay, last question. What if instead of doing an SRS, what if the botanist asked the farmer to choose which trees he would like to be tested? Okay, it's kind of like a convenience thing, right? It's kind of like, hey, can you just tell me which trees I should test, you think? Okay. Now, from this perspective, the reason why this can have a bias is if you had a farm, if you had a bunch of trees and you're trying to figure out what's happening with them, and just a little thought experiment here, right? You're this farmer and someone's like, hey, which trees should I test? I'm thinking right now, if I was that farmer, I would probably tend to say, well, I think this one, these ones over here, you might want to test those over there. I think they all have this disease. So that's no longer random, right? You just selected trees to pick, and there's a good chance the trees that were selected are all going to come up with having this disease or the fungus growth or whatever it is, okay? So that would give you biased results. Okay, that would give you results that don't give a good reflection of the entire population of all the trees. You're only looking at the ones that potentially are sick. Okay, that just ignores the data you're trying to collect. Okay, the data that's trying to be collected is to figure out roughly how many trees potentially could have this virus, this disease. Yeah, the trees have COVID. No, not a joke, but seriously, either the tree is either like diseased or has fungus, okay? And the farmer's probably going to pick the ones he thinks has it, right? So it's going to be skewed data. All right. The farmer may select trees he believes have the blights. Therefore, there would be an overestimation of blights. I think I'm using that word in the proper context. Okay, at this time, I will stop this recording and I'll try to answer any questions you guys may have, okay?